All right, thanks for joining me again. So I'm going to teach you some stuff about a slicer. What is a slicer? Why is it important? And how can it be really helpful for 3D printing? And it's necessary for the 3D printing process. This video is sponsored by PCBWay. PCBWay makes custom printed circuit boards. That's what PCB stands for. And they have thousands of different components to choose from. I mean, they've got flexible circuit boards, extra thick circuit boards, crazy circuit boards. You can do different shapes. You can make it like a Christmas tree if you wanted to. It's crazy. Also, they have a service where you can actually send them your design files for a circuit board that you want to build, and they can actually build it for you and add all the components, and they'll test it before they even send it to your door so it's ready to go. Also, they offer rapid prototyping services to include sheet metal bending, injection molding, 3D printing, and CNC machining. So if you like doing these kinds of things, or maybe you don't have a 3D printer, or maybe you don't have some other kind of machining tool, you can send your design file to them, and it's a really quick and easy process. If you're looking to get some rapid prototyping done, that may be interesting to you. I'll have links down in the description below this video. Thanks, PCBWay. Now back to this video. Congratulations if you started 3D printing or you're thinking about it. So first of all, a slicer is kind of the second part of the process of 3D printing. The slicer is just the name that we call the software that actually sort of slices up the model, and it makes it so that our 3D printer machine will know how we want to print that model. And I'm going to show you what I'm talking about in this video so that you'll be able to do this and get your first prints going, hopefully with more success. So first of all, I'm going to be using Ultimaker's Cura. Cura is the name of the software. And this is a very common slicer software, and you can use it on Mac OS, Windows, and Linux. If you have a Chromebook, you're going to need to use something that is just browser-based. So you can download that for free from the Ultimaker website. And then when we go into the program, it's going to look like this, and you're going to have this build plate. This grid right here is the build plate. And then probably the first thing you're going to want to do is get your 3D printer profile in here. So we're going to come up to the top left corner, and I'm just going to show you this, but you can pretty much apply this to all slicers. We're going to go to Add Printer. Let's say it's a non-Ultimaker. Let's say you have like a Creality or something. We're going to click Add Non-Networked Printer. Let's just grab ABC Creality 3D. Let's say we're using Ender 3 V3 SE. I'm not even familiar with that one, but let's use that one. Okay, we're going to click Add, and then these dimensions and everything should be correct, but this is basically the main difference is the size of the print bed, you know, whether you have multiple nozzles, things like that. So this should be all correct for your machine. We can click Next. All right, so that was that part. Right here in the middle, you'll see what we're working with is just generic PLA. That doesn't actually affect the print, but you do want it to be a 0.4 nozzle size. That'll be helpful there. And that's because that's typically what your 3D printer is going to have. First of all, we need to get a model. So I have a model right here. I'm going to use this one that I designed. This is the Dumb Pro. It's basically a GoPro dummy model, and I'm going to just drag and drop it right into Cura here. And of course, if you want to download these .stl files, these models for 3D printing, you can go to thangs.com, you can go to Bamboo's Maker World, you can go to Prusa Printables. There's a lot of different places, very easy to find these. So for controls, you can click using the left mouse, and then you can click and hold the right mouse, and you can rotate around the item that you've selected. Okay, and you'll see on the left hand side, first I'm going to show you the most basic use of a slicer. Okay, so actually just to demonstrate that, so bottom right hand corner, we'll click Slice. Okay, it's going to go through the slicing process. You see it estimates how long it's going to take. Click Preview. This is really what we want here, this preview. And on the right hand side, you'll see there's a slider, a vertical slider. This is really your bread and butter of the slicer software. So you see this is sliced up into layer segments. So each part of the model is going to be printed one layer at a time, and you can drag through the layers. So you can see we're at layer 130. You can drag it up and see how it's going to print. And this is really useful because like right here, for example, oh, and you can use your scroll wheel to zoom in and out. Otherwise you can use like the, I think, command plus and minus buttons. So if we scroll up, so first of all, it's going to start like this. Okay, we're going to print our first layer, and then we're going to, the machine is going to build on every single layer from there. All right, so the things you want to watch out for when you're, part of the reason why we're using this slicer is to make sure that this will print properly. Right here, you see this right here? That is called an unsupported overhang right there at layer 92. So if we rotate this, you see that? It's so, and what we can actually do is this bottom slider in the middle here, that will show us the actual tool head or the nozzle movement. So you see the ghost nozzle right there. You can see what it's doing, the order that it does it, and you see how it does these external layers, or the wall layers. It does those first, but you see here it's just printing over nothing, over thin air. And so what that's going to do is gravity is just going to pull that down, and you're not. It's just going to fall down. Maybe eventually it'll start to build up, you know, once the plastic cools, but that's not what we want at all. So that brings us to the other features of the slicer. And so what we're going to do is up at the top, we're going to go back to prepare, which is going to bring us back to this window. Let's click on our object. And what we want to do is actually rotate this. I designed this to be printed upside down. And so what we can do is click on the object on the left-hand side of the screen here. You'll see we have some options. We can move the object. Okay, we can just click, left click and drag the object around on the print bed. Okay, and we can actually, this blue arrow is our Z axis, which is like the up and down. And we can move it up and down if we want, but it's automatically gonna fall flat to the print bed because you can't just print something in midair. That would be silly. So what we actually want to do is rotate this. So we can, you do have the option to scale it, but we don't want to do that right now. We want to rotate. So, and you can also press R on your keyboard to make this happen. And then let's see, let's rotate this here. Okay, so what we want to do is we can actually just click these arrows here to rotate it in the direction that we want. So we actually want to rotate it so that this top part is on the bottom. So we just click the arrow, it's going to rotate it 90 degrees. And if you don't want to snap 90 degrees, turn off this snap rotation, and then you can click on one of the axis kind of arrows, and then you can drag it any number of degrees that you want to. Okay, but let's reset that. And then here's another thing you can do. You can actually lay it flat on the build plate, which it already it's going to automatically decide how it wants to do that, and it kind of already did lay it flat. But the other thing you can do is select a face to align to the build plate. So this this works most of the time. So you can click that button and then select, like, let's say we want this side to be on the bottom. There we go, boom. So that usually works, and it can save you some time to just do it automatically. But right here, you see how there's this little gap right here at the bottom? There's a little tiny gap right there, okay? And, oh, and if you press and hold your mouse wheel, if you have one of those types of mouse, you can move it around like this, kind of like in a straight up and down sideways direction, okay? In any case, you see there's this gap here, okay? So if we were to try to print that, it would just try to print that little button on the bottom, but all this in red, it would not be touching the build plate. So what we actually want to do is click on our object, go back to our move selection, or press T on your keyboard, and we actually want to drag it down until we see that the entire bottom of this model is touching. All right, now, you know, you may not need to do this kind of thing for every model, but this is just an example of what you can do to make your model print better. Now I'm going to lose that button feature on there, so that's kind of a bummer, but that's just kind of how I figured I would need to do it anyway. And what that's going to do is it's going to allow this little camera lens piece to touch the bottom, and then we won't have an overhang. Same as with the kind of the inside portion, we're not going to have an overhang. So now let's click slice and preview. Okay, and then we can scroll through this here. All right, I know it looks all crazy. Those are the different lines, and I'll explain what those mean in just a moment. So those are the different lines, and so there we go. So we can see this going to be a nice, large surface area, flat on the build plate, and we can build up from there. So this will print properly, just like that. We shouldn't have any issues. Okay, so that's the most basic stuff right there. At this point, you can just hit, save to disk, and then you can choose where you want to save it. And okay, I will allow that. And you can rename it, and it's going to be a .g code file. And that means that a .g code is ready for your printer to read that file and be able to print. Because we've set this up for your particular printer. So we're not going to do that yet, though. Up here at the top right corner, this gets into some more options that we can do. And right now it's set on standard quality, and the options menu is set on basic. And that's fine. Like if you want to just start printing some stuff, just give that a try. Probably the very first thing that I would want to change would be the material temperature. That's going to be your printing temperature, and that's going to vary based on your filament that you are using. So check your filament. It should say on the roll of filament the temperature range, and that's in degrees Celsius. 200 is probably fine. I typically go, maybe 220 or maybe 215 for the type of PLA that I use, and that's probably what you're going to be printing with to start with, is PLA. So that would be probably the most important thing to change. And then also the speed. So 180 millimeters per second, that's actually really fast, and I'm not sure why it's set so fast, because that's very fast. Typically it's set to 50 millimeters per second. Or you could even go lower, especially if you're printing with some materials like TPU or something flexible like that. So those are the most important ones, and we'll go through all of those in just a minute. One thing I want to point out here on our left-hand side, there are a couple more options. You can do mirroring, which I don't find that helpful. You can do per model settings, that's kind of more advanced, and then you can do a support blocker, that's also more advanced. So don't worry about those at the moment. Now let's go through these settings one by one, and I'm going to explain what each of them does and kind of how important it is. So first of all, quality, layer height. All right, so that is going to determine how tall each layer of this item is. And so what that means is, so right now it's set to 0.2, and that's like pretty much the standard. I would leave it at that. But when we slice it, you're going to see, and we click preview, you're going to see all these lines here, okay? Each layer is 0.2 millimeters, which is really quite small, but you can even go smaller depending on, how good and calibrated your machine is, and you can go a little bit bigger. Some of that is going to depend on the nozzle diameter, the size of the hole in the nozzle that's actually extruding the plastic. So you don't want to try and do a crazy number. You're going to kind of need to change out the nozzle to get a bigger or smaller hole depending on how fine of detail you want, or resolution is sometimes what this is called, the layer height, because there are more lines means you have better resolution. So speaking of lines, let me take a minute to actually explain what we're looking at here, and that'll make more sense for these different options in the menu. So right now, if we look at the top bar in the middle here, it says color scheme line type. Click on that, and you'll see that one, it gives you a little key or a little legend to explain what the different colors mean. And you can also change kind of how we see this model. Line type, this is the most important thing. So you're going to have your walls on the outside, So the red is going to be your exterior walls, green is your interior walls, and don't freak out if you're like, this sounds like a lot. Just kind of take a little bit of note of this. The most important thing are going to be your walls and then your infill. The infill is orange. The travel, that shows the actual movement. Whoops. Oh no, I got rid of it. That shows the actual movement of your tool head. You can turn that off because sometimes it can get like a lot. Like it seems like it's distracting basically. So the travel, see how all that blue stuff, we don't really need that to see kind of how it's going to print. So that's what I want you to pay attention to. I'm going to reference that. And then the yellow is your top and bottom layers. Okay. All right. So that can be helpful, especially as you get more advanced, but don't freak out if that seems like a lot. Back to our print settings here. So we have the layer height. So basically keep that the same for now. And then you can play around with that later on. Our walls. So our walls, it is measured by this will tell you the wall thickness. Oh, and if you just hold over the option, it'll give you some information about it, which can be really helpful. And our wall line count. So we have 2 walls, and so that's going to be one is an outer, one is an inner. So like just to show you, let's say if we say, okay, we want, I don't know, 7 walls. All right. So keep an eye on the walls here. We're going to slice it. Every time you make a change, you have to slice it. All right, look at that. So all of our infill, almost all of our infill. Oh, and the infill is just the inner material that's not a wall, basically, but it's part of the print and it's used to support and it's to make the print stronger, basically. But look at that, all that green. So we still only have like one exterior wall, and that's in red. Oh, I guess, and the interior wall. So it's kind of like sandwiches it. But all the rest of that is in green. And so those are really thick walls, okay? So the walls are going to be, that's really going to help with strength, but we don't really always need a ton of walls. And it can take more time to print depending on the type of model that you have. Okay, but that's what's going to happen there. I would set it, I like 3 walls. You can get by with 2, but I think 3 is a really good number, and it's going to be nice and strong and all that stuff. So I'd suggest 3. Okay, your top and your bottom, the top and bottom thickness, and you can just change how many layers and it will automatically change the thickness. So don't worry about trying to figure that out. 4 layers, that's plenty. Sometimes that's too much, honestly. We could take that down. Usually you want at least 2, otherwise you might start to see that infill, the infill lines on the inside. And so you do want a strong top and bottom. But sometimes that can also take up a lot of time in your print because you see all the surface area. It has to do every single one of those lines 3 times or 4 times or however many times you set it. Okay, so that can take up a lot. So generally speaking, the more infill, the fewer walls and the less layers you have for the top and bottom, the faster it's going to print, but it won't be as strong. Okay, so that's the top and the bottom. You could play around with it, but I would say 3 should be good for both of those. All right, infill. So here we just have the infill density and then the infill pattern, okay? So, and this is cool because you can really kind of play around with the density here. So they have cubic by default. I don't know if cubic is really the best for everything, and I think it takes a lot of extra time and stuff. So let's and you can kind of check that too. When you slice it, you can see if it's faster or slower. In any case, just to give you an example, a really common one is lines or a grid. Grid is going to be stronger, but you have all these other options. But really, I would probably just go with lines because you get a lot of support for the density. I think so. For example, 20% density. Look how much closer these are than the cubic infill that we had. And what that's going to do is it is going to help with the strength of the print, but it will also support the top and bottom layers, or anytime that you have filament going across this, the smaller this grid of infill, the better the print is going to turn out, because then it won't sag. So it's going to be supporting the lines as it goes across. I hope that makes sense. So really, we could probably change this to 10%. Again, it depends on your model. It depends if you're really going for a lot of structural integrity, or you just want it to you know, kind of take up space basically. All right, I think 10% is probably fine for this. Yeah, I think that's good. Because if you have, you know, too much, then you're just going to waste it and it's just going to take longer to print, you know. But again, depends on the model. Okay, that was infill. Now let's move on to material. We already mentioned material. Check your filament roll to see what the recommended printing temperature is. And then for the build plate, so the build plate temperature, that's how hot your build plate is. This whole thing right here, this gray area, that's what your printer actually prints on. And you want that to be hot because that will help keep the filament sticking to the build plate. And if it's not hot enough, what can happen is your model can come off of the build plate during the print, and it will unstick. So having this hot, like 60 degrees Celsius, you can be pretty sure that it's not going to come off the build plate, especially if you have, you know, a modern surface that you're working with, like a textured PEI plate or something like that. You could drop that down to 50 if you want. We'll just leave it at 60 for now, especially if it is, if you're the room that you have your printer in and it's not an enclosed printer. If the room is cold, you may still want to keep this at 60, so that way it can kind of fight the heat loss. Let's go to speed. So we did talk about speed. They had this set at, I think, 180 millimeters per second. I'm pretty sure that's really fast. I don't know why they'd set it like that, but you can play around with it. Basically, with the speed, you know, I would say start slower and then increase the speed until it's not printing well anymore, and then you can kind of back down the speed a little bit to make sure that you have a good print. Because, you know, I'd always rather have a good solid print and reliable print instead of trying to make it go really fast and then have issues with the print later on, like it's bad quality, or it maybe it gets knocked off the build plate for some reason because it's trying to print too quickly. So travel, they just have two settings here, and you can pretty much just leave this alone. I would just leave this alone unless you have issues and then you need to like troubleshoot or something like that. Z-hop, like it says here, is when the build plate is lowered or the nozzle is raised, so that it prevents it from hitting the print during travel moves. You could turn it on or not. Let's go ahead and turn it on. It might help, it might not. It kind of, you know, that's a little more advanced troubleshooting there if you do have issues. All right, cooling. Print cooling, that's that little fan that blows on the nozzle tip. So not the fan that cools down the heat sink or the hot end, but this is the actual part that cools down the plastic as it comes out of the nozzle. We do want to enable print cooling. Fan speed, this is something that you may need to play around with as well. If you have too much fan speed, that can cause the filament to cool too quickly and you won't have a strong print. Or if the fan is really strong, it could cause the fan to actually like blow the filament away. Or like with bridging, this comes in with bridging, which that's kind of more advanced, but that's basically when it's drawing a line of filament in midair to connect kind of like 2 points, and they call that a bridge. In any case, the fan cooling, I just keep it at 100% unless you start having issues with your print. If you don't have any fan cooling, or if you don't have enough, what can happen is you get like these kind of saggy looking prints where the filament kind of oozes too much and doesn't cool quick enough as it comes out of the nozzle. Support. So support is, like it says, it supports the model. I really don't like to use support unless I absolutely have to. I'm going to turn it on to show you what it does. So in this model as we have it, we probably don't need it. And that's why I like to rotate the model and do whatever I need to do to not have to use supports, because supports can be a pain in removing it from the model, and also it uses filament and takes longer to print the model. It's taken a super duper long time to slice this for some reason, and I don't know why. So I'm going to click cancel on the slicing, and then what I'm going to do is I'm going to press the R letter, and then I'm going to rotate this. I'm going to click it twice so that it is back kind of how it originally was, in the upright position here, like that. And then I'm going to click generate support, and we'll try that. Let's click slice, generate support. There we go. That seemed a bit faster. Okay, so these blue lines here are the support. All right, and the support is there's a lot of it. There's a lot of support here. Too much support, in fact. And so this is why I don't like to print with support unless I have to, because it makes it take longer and it uses up more filament, and you don't get as nice of a finish when you remove the support. So for example, right here where this lens is overhanging, if we printed this, you know, in this orientation, you see right there, all of this filament here is just to support that layer. That's all that's for. And then on the inside, we have all that filament to, when we get to, where is it, bridge over, about to, right there. Right there. So all of that is just to support that roof. And so that's why we can just avoid pretty much all this support by rotating the model. But that's what support does. You can change some options here. You can change the type of structure. You can change it to like a tree, and you can change it to where it is only touching the build plate, or if it's like within the model, and then the overhang angle. But let's see, let's slice that to show you what it looks like. Yeah, so that's what a tree looks like. A tree, I think, actually works a lot better, or at least it looks like it will work a lot better. Sometimes what can happen is these little trees will fall off of the build plate, or they'll become unstuck from the build plate because there's not as much surface area. And we can change that with build plate adhesion. Now we have build plate adhesion. So right now it's set to skirt, and you've seen that. That's that line that goes around the model. I'll just show you right now. So a skirt, it really doesn't help adhere it to the bed. The skirt basically just goes around the perimeter of the model, like that. And that can be helpful sometimes to kind of get the filament flowing, but sometimes it's not that helpful. So a brim is better for getting the model to stick to the print bed, and that's what this is for. It's to get this to give it more surface area to stick to the print bed. So on here, they don't give you any options. In the basic settings, they don't give you any options of the size of the brim. If you go to more advanced options, you can change that. But that's what that is, just so you know what that is now. So if you're having problems with something sticking to the print bed, try giving it a brim, and that should help a lot. But you will have to peel off that brim from the objects. So just keep that in mind. You can also do a raft, which I rarely ever do. I think I've done a raft like one time. And that actually builds up like a whole layer of the print to print the print on, if that makes sense. So that's all plastic, or that's our filament, and I think it does what, 1, 2, 3, something like that. And then we build our model on that. So I guess if you really had problems with it sticking, you could do that. Or maybe if the bed, I don't know, if the bed wasn't level, that, I don't know. There are some uses for a raft, but I prefer not to use that. All right, we're almost done. Dual extrusion. Well, I don't even know why that's on here, because our printer doesn't have a dual extrusion. So that's it. One more thing I forgot to mention is this right here. These little colorful bars right here. That's the home corner. I think that's kind of what it's called, of your printer. So your printer will have a home position where the print head goes, and in this printer, that's where that is. So like as we're referencing this, this is how it's going to look on the printer as it's printing. Just want to let you know that. So let's click Save to Disk once we're happy with it. You name it whatever you want, and then it's going to have that .g code file. Save it to a folder, and then once you save it, you're going to, and you'd save it. I'm just going to cancel it for now. You are just going to grab that file, put it on your SD card, and then put your SD card onto your printer. Unless you can do it wirelessly, but that's going to depend on your printer. Thanks so much for joining me. I hope this was helpful. If I left anything out, please leave a comment down below, or if you have any questions about this kind of thing, and I can answer it, or maybe somebody else can answer it. Thanks for watching. Have a great day. Bye.